All right, let's talk about the A-level physics paper 5 planning question. You know the one, it's that big 15-mark challenge where how you structure your answer is just as important as the science inside it. Today, we're not just going to look at it, we're going to build the perfect answer, piece by piece, mark by mark.
So let's kick things off with a question that, probably drives a lot of you crazy. You get the physics, you understand the experiment, so why on earth do those crucial marks just seem to vanish?
Well, the answer is actually simpler than you think. This question isn't really a test of your physics knowledge, it's a test of your technique. It's all about how clearly and methodically you can communicate your plan. Success here is all about structure, clarity, and basically following a winning formula.
So here's what we're going to do. We are going to build that perfect answer by breaking it down into 5 key sections. And the best part? These sections are a mirror image of the examiner's mark scheme. So let's dive right in. Okay, Section 1, defining the problem. This is where you'll bag your first 3 marks. Seriously, think of this part as the foundation of your entire answer. If you get this right, everything else becomes so much easier.
So, the very first thing you've got to do is nail down your variables. This immediately tells the examiner that you get the logic of the experiment. You need to clearly state your independent variable, that's the thing you're going to change, then your dependent variable, the thing you'll measure, and finally, your key control variables, all the things you have to keep the same to make sure it's a valid test.
And this is a big one, folks. You have to be super explicit. Never, ever just write a single word like temperature. No, you need to be precise. Say something like, the temperature of the water, which will be measured in Kelvin using a digital thermometer. See the difference? That level of detail is exactly what they're looking for. It shows you're thinking like a real scientist.
And the same rule applies to your control variables. Please, whatever you do, don't just write that you'll keep them constant for a fair test. That's way too generic and it won't get you the mark. You have to explain why using physics. For example, the ambient air pressure must be kept constant because any change would directly affect the boiling point of the water. That shows real understanding.
Okay, now we're getting to the absolute beast of this question, methods of data collection. This section is the big one. This is where you can earn up to 9 marks, which is more than half the total. So let's figure out how to lock down every single one.
Yeah, you heard that right. A whopping 9 marks. This is where the game is won or lost, honestly. The level of detail and clarity you provide here is absolutely critical. So, the first 5 marks come from your core method. Think of this as your 5-point battle plan. First, you need a big, clear diagram, and it has to match what you write. Second, for every variable, you describe the action you'll take and the instrument you'll use. And finally, you pull it all together into a logical, numbered, step-by-step procedure that anyone could follow.
So how do you go from a good answer to a great one? That's where these next 4 additional detail marks come in. This is where you show some real experimental savvy. You mention things like repeating your readings and taking an average, or making sure your instruments are calibrated. You could even add clever little tricks, like painting one blade of a fan a dark color to make timing its rotation way easier. Just dropping in 4 or 5 of these details shows you really know what you're doing.
Next up, the analysis. So you've collected all this imaginary data. Now what? Well, you got to tell the examiner exactly how you'd process it to prove the relationship they gave you in the question.
And honestly, it's a pretty straightforward 2-step dance. First, you're going to manipulate the equation they give you to turn it into the form of a straight line, y equals mx plus c. And second, you're going to describe exactly what that straight line graph would show you.
So what does linearize even mean? It's just a fancy way of saying we're going to rearrange the formula until it looks like the equation for a straight line. Why? Because plotting data that gives you a straight line is the absolute best and most reliable way to check if a relationship is true. This table gives you a few common examples of how to do that.
So once you've figured out what to plot on your y-axis and x-axis, you have to describe the graph you expect. You'll say that if the relationship holds, you'll get a straight line, but, and this is the crucial part, you have to explicitly state what the gradient and the y-intercept of that line actually represent in terms of the constants from the original equation. That's where the marks are.
All right, let's grab an easy mark that for some reason tons of students just leave on the table. Safety. It should be a gimme, but there's a trick to getting it right. The golden rule here is be specific and relevant to your experiment. Generic answers like wear goggles will get you 0 marks. You have to link a real hazard from the setup you just described to a specific precaution. So if you're using a fan, you talk about dust. If you're using hot water, you talk about burns or spills. Make it make sense. Okay, last section. Let's talk about the big picture, your overall strategy. Because how you present your answer, how you organize it, is almost as important as what's in it. A clear layout makes it easy for the examiner to give you marks.
So on the day of the exam, use clear headings that literally match the sections we just talked about: defining the problem, method, analysis, and safety. This turns your answer into a roadmap. It lets the examiner just tick, tick, tick their way down their checklist. Trust me, a well-organized answer is almost always a high-scoring one.
If there is one single idea you remember from this whole explainer, please make it this one. Examiners mark against a checklist. Your job is to make your answer become that checklist. Don't think of it like writing an essay. Think of it like you're building a clear, technical report that's designed to be marked easily and accurately.
So let's do a final run-through of your full marks checklist. You're going to identify your variables with precision, describe your method systematically, sprinkle in those specific experimental details, linearize the equation correctly, interpret what your graph actually means, and finally, add a smart, realistic safety precaution. You hit every one of those points, and you're golden.
Look, at the end of the day, remember, this question isn't about trying to memorize dozens of different experiments. It's a test of your logical thinking and your ability to be a clear communicator. It's a predictable challenge. And with this structured approach and a bit of practice, it's one you can absolutely nail. You've got this.